Welcome students to Pradeep sir classes as PSC where Logo can talk the physics. And we are in IIT Foundation course ICSE-10 and this is work, power, energy and this is chapter 2 and lecture number 2. Okay, so if you are first in that class, then go back to the previous classes, that is lecture number 1, work, energy, power, then you are able to do that particular one. But before that one, I recall that particular classes, that is we discuss first of all students the concepts of work done. What is the equation for this one? There is W equal to Fs cos theta. There is the component of force along the displacement or the displacement along the force, and the last one is the unit of different unit. There is the absolute unit, the gravitational unit, and what is the relationship between the uh, absolute unit, that is the arc and joule, the relationship between arc and joule. Okay, so first of all students, you have to note down that particular equation related with this, and today we are discussing about the numerical. So the formula used here is work done equal to Fs cos theta, where theta is the angle between the force and the displacement. If this is an object and if forces act along this direction and the body move along this direction, so this is angle of inclination and this is the displacement takes place. So this is the displacement, then you can say that the component of force along this direction is F cos theta, and F cos theta into S, that is the product of force and displacement. This is work done. Okay, so this is the formula one, and the unit of this one is joule, and joule equal to Newton into meter. So joule equal to Newton into meter, and arc equal to, there is 1 joule equal to 1 Newton. You can say that 1 Newton into 1 meter. Similarly, 1 arc equal to 1 dyne into 1 centimeter. 1 dyne into 1 centimeter. And the relationship between the joule and this one is 1 joule equal to 10 to the power of 7 arc. Dear students, it is given the force is in kg force. The force is in kg force. Then you have to convert with 9.8. Multiplication of 9.8, and there is 9.8 Newton, and if it is given in gram force, then you have to multiply 981 or 980, and this is dyne. So these all are the units and formula used for the numericals, and you have to take a habit of just note down the numerical. That is, we are starting with the numerical number 1, and just students, so write down this first and then try and then pause the video and solve this one and then check the answer. So question 1 is, a body when acted upon by a force of 10 kg. So the force is given, question number 1, and the force is 10 kg, 10 kg force. So this is 9.8 into 10. G equal to, you have to take 10, so 10 into 10, so this is Newton, so 100 Newton force is applied. Okay, so the first one is, a body when acted upon by a force of 10 kg gets displaced by 0.5 meter, 0.5 meter. So the displacement is 0.5 meter is the displacement. And when the displacement, so you have to calculate the work done when the displacement is in the direction. So for the first one, the work done is Fs cos theta, and here given theta equal to 0 degree, since this is the object and it displaces the object along the direction of force, So this is theta equal to 0. So Fs cos 0 degree, and this is 1. So the formula is W equal to Fs, or the force is 100 Newton into 0.5 meter. So this is 50 Newton into meter means joule. So 50 joule is the answer. Is it clear or not? I think the concept is hidden at that particular concept. If the object is displaces along the direction of force, then you have to take theta equal to 0 degree. But students, for the next one, if force is applied along this direction, that is, force is applied along this direction and theta is equal to 60 degrees given, and the displacement takes place along this direction. In our childhood, most of you are familiar with that one, and a card is drawn with a particular thread along a particular direction. We tied a rope with a particular object and drag that particular object along a specific direction, but the object is moved along the floor. If you want to push that one along this direction, then it moves along the horizontal direction. So there is an angle of inclination exists, and the force is divided into a specific component that moves the object along the horizontal position. So then you have take the formula as Fs cos theta, and here F is also given 100 and S is 0.5, but the cos theta can decreases the force. So cos 60 degree means half. So 100 into 0.5 into half. So this is 50 into 0.5. So 25. So 25 joule. Or you can say that since cos 60 degree is half, so 50 by 2, that is 25. So 25 joule of work is done. But if, and for the next one, for the case third, case number 3, normal to the force. So the displacement takes place if the force is given along this direction and the body move along this direction. Then this is 90 degree and the work done is Fs cos 90. So students, cos 90 equal to 0. So the work done is 0 for the next one. So the numerical, I think for the question number 1, it is so simple, but the concept, the hidden concept within this is so amazing. What is about positive work? What is about negative work? What is about zero work? All the concepts are given within a particular numericals. So students, let's try for the next one. The question number 2. Write down again this one and try again. And you can easily solve this after seeing the concept or seeing the answers. So question number 2, a boy of mass 40 kg runs upstairs and reaches the 8 meter high first floor in 5 seconds. And the force of gravity acting on the boy. Okay. So the boy, and this is a floor. This is a floor, and this is, suppose the student, this is first floor, and the boy upstairs move and stay at that particular one. Here, this is first floor. So a boy of 40 kg. So the mass of this one is, mass of the boy is 40 kg. Okay, 40 kg, and runs upstairs and reaches the 8 meter high first floor. So it is 8 meter high. 8 meter high first floor in 5 seconds. So the time is, here time is also given, there is 5 seconds is given, 5 seconds. Calculate the force of gravity acting on the boy. So the force of gravity act along this direction, this is mg, and we can easily calculate, this is first mg equal to mass is 40 and the value of g is given, that is 10. So this is 400 Newton gravitational force act along this direction. The work done by him against gravity. So against gravity, it doing some work. So against gravity, the work done is equal to mg, that is force into displacement. So force equal to mg, and the displacement is given. Suppose it is h. So mgh, that is 40 into g into 8. So this is 3200. So this is a 3200 joule of work is done against gravity. Against, what is the work done by the boy? This is 3200 joule. But if I say that what is the work done by the gravity, then it is negative, minus 3200 joule. So against the gravity, the boy is doing some work, that is positive, but the work done by the gravity is negative. If it is given, what is the work done? If it is say that what is the work done of the by the gravity, then you can say that this is also 3200, but in the negative direction. Okay, so against gravity, the boy have to lift himself with some distances, that is 1 meter, that is on the first floor. Okay, and the next one is power spent by the boy. Power. So I write down the formula. Power equal to work done by time, and I explain that particular one. First of all, students, this is my mistake. I have to compute the work done as well as power, but I explain this one. First of all, this is the work done, then power, then energy. Okay, so just write down this one for that particular numerical. So work done by joule time. How much work is done in a specific time, that is called power. So power equal to joule by second. So this is watt, and you can simply write as W, capital W. You can write as capital W, that is watt. So 1 watt work is done. 1 watt, the power of the boy is 1 watt when he do some work of 1 joule in 1 second. So if a boy can do 1 joule of work in 1 second, then we can say that the power of the boy is 1 watt. So what is the power spent by boy? So power equal to work done. So work done equal to 3200, and the time is given. So time is 5 seconds. So 5 6 30, and then 5 4 20. So 640 watt. So 640 watt power is spent by the boy, and this is also completed that numericals. And students, for the next one, write down the question number 3. Question number 3, and similarly, first of all, try with numericals, and then students, this is a mainly this is a numerical, and I love to solve the different numericals. So this is actually a numerical based and concept based channel. We don't go for the different definitions, but for the class 10 I explain elaborately with definitions also, but most of all for 11th and 12th, for IIT, for advanced students, for JEE main, or for that particular one, and you can follow from the first one, that is from 10, so that I prepare you with a specific analytical brain. Okay, so let's write down the question number 3. Question number 3. It takes 20 seconds for a person A to climb up the stair, while another person B does the same in 15 seconds. Okay, climb up the stair. Compare the work done. So A and this is B, and they climb up a stair. Suppose he want to move here. This is the upstairs, and it takes 20 seconds. 20 seconds for a person A to climb up the stair. 20 seconds, and it takes to move this one, and he also move this one, and it takes this is A and this is B, and the time here is 20 second, and B does the same. This is in 15 second, 15 second. So you have to compare the work done and the power developed by the persons A and B. So the work done, same work. So this is the work done by A and this is the work done by B. So since they do some work with a different second, but the work done is same, so you can easily say that. And if I take along this direction, suppose you think that this is mg and he lived a particular specific distance h, then mg into h is the work done for that particular one, mgh. And for this one is also mgh. If the same boy can do, if the mass is different, or the boy A and boy B, if the persons is different, then mass is also different, then work done is different. But if the mass of this boy and if the work is same, work done by this one is same, and so we can write as, since it is given the work done is same work they do with 20 second and the next one is 15 seconds. So mgh, this is also mgh, and you can take a ratio of this one and this one. So this and this is equal to 1. If the two persons are different, and they lift themselves with a particular height, then the work done must be different. So for that particular one, if it is said that the work done is same, so we can say easily the work done, ratio of the work done is this one. But the power of this one, power of A equal to work done by time, so this is time is 20 second, and for the B it is work done of B by this is 15 second. So the ratio of power, PA is to PB. So this is this by 20 is to, this is equal to W of B by 15, and this and this one are cancelled, and if you multiply with 60, then 1 by 20 into 60 is to 1 by 15 into 60. So this is 3 to the this one and 4. So this is 3 is to 4. So the power is the ratio of the power is 3 is to 4, whereas the work done by the this one is 1 is to 1. And students, write down the next one. A boy weighing 350 Newton runs up a flight of 30 steps and each 20 centimeter high in 1 minute. So it is also a very simple one. So this is question number 4. So this is question number 4, and the students, a boy weighing 350 Newton. So the force is given, that is 350 Newton, and runs up a flight of 30 steps. So the displacement is 30 step. So 30 into each is 20 centimeter high. So 20 by 100. So this is 3 to the 6 meter. Since this is given in centimeter CGS unit, so you have to compare with a particular system of unit, and the time spent is 1 minute, that is 60 seconds. Calculate the work done. So work equal to force into displacement. So force is given and the displacement is 6. So this is 0, 5, 6, 30, and this is 2100. So 2100 joule work is done by this one, and the power spent by this one is work done by time. So this is 2100 by 60, and this one are cancel this one. So 3 to the 6 and 370, and 3 to the 6 and the 5, and this is 5. So 35 watt. So 35 watt power. So all the numericals are given with some specific formula, that is W equal to Fs cos theta, where theta is a specific angle between the force and the displacement, and the related one is power. What is the power? Explained or spent by that particular work done. So here students, the power in horsepower, the next one is something, a different unit is used here. So students, for the next question you have to remind horsepower. What is horsepower? Horsepower means 746 watt. It is a large unit. When this is 746 watt, then you can take as 1 horsepower. 1 horsepower equal to this one, 746 or 0.746 kilowatt. You can say that 0.746 kilowatt, kW. So 746 watt, it is a large of unit. We can take suppose when it is the 1000 meter, then you can say that this is kilometer. Okay, so like that one, when it is this one, or you can divide this with the 1000 and this is kilowatt, so it is 0.746 kilowatt, and horsepower is a large unit. Okay, so the next numerical is, a man spends 6.4 kilojoule energy in displacing a body by 64 meter in direction in which that applies force. Okay, so this is question number 5. So question number 5. So the question number 5 is, a man spends 6.4 kilojoule energy. So the work done is given 6.4 kilojoule. What is kilo, students? You have to multiply this one with 1000. So this is joule. So 6.4 into 1000 joule work the man energy is spent in displacing a body by 64 meters. So the displacement is also given. This is 64 meter. In the direction in which the applied forces is in 25, and the time is given. This is 2.5 second. This is 2.5 second. Time is given, and calculate the force applied and the power spent. So the force equal to work done equal to force into displacement, and here it is given the theta equal to 0 degree, since the force acts along the direction of displacement. So the force is force equal to work done by this one. So force equal to work done by displacement, and the work is 6.4 into 1000 by the displacement, that is 64. So if you move this one, so a 0 cancel this one, and this cancel this one, so 100. So 100 Newton force. So this is 100 Newton force. And the next one is the power spent in horsepower. So the power equal to work done by time, and the work done is 6.4 into 1000 by time is given. So time is 2.5, and you can move this and this one. So this watt is the answer, and you can easily cancel this one. So 42500, this is 40, and the power is 0, 4 4 just 16, and 2560 watt, and you can divide it this one. This is the watt, and you can write as 2560 by 746 horsepower. Okay, horsepower, then you get 3.43 horsepower approx. Okay, so this is the value of power spent by the man. So students, I think I clear your concepts day by day. with a new and more different classes, more exciting lectures. And if you think that this is my best educational channel, then please subscribe with your and share with your friends. Okay, and let's continue the study. Thank you.